us to watch kind of thing. Is that just I remember?
I soon need your help again. All right. Ava, Vanessa, there's something interesting about Vanessa. My daughter came with me this morning. I wanted to introduce you to my daughter, but she went to the library. Is Vanessa there? Is Vanessa the one that is in forensics? Where's Vanessa?
She's online, but
hello?
I don't know if she's talking today because of her throat issue.
Whoa.
She's in forensic, yeah, Vanessa.
Okay. Probably Vanessa should try chewing on a raw piece of garlic if you're not hypotensive. It works for me when I have a throat infection. Garlic itself, but it's kind of harsh if you chew on it, just like that. But it does work. Drinking garlic tea afterwards, but chewing on it like that kind of help. So I need to, all over the weekend I didn't get any practice. I just need to get myself back a little familiar with this. But let me hear from, who is this now? Ashley. I think I heard Ashley's voice a while ago.
Yes, good day.
Good day, Ashley. How are you?
Very well.
Oh, what did you do over the weekend? Did you go to the beach?
I didn't make it to the beach. I was working a bit and just doing a lot of communicating back and forth with people. And I went to the movies with my dad and dinner with my dad.
I'm not hearing what else you're saying. After you what a break.
Sorry.
After I heard you say dad went to the movies with your dad?
Yeah.
After you say you went to the movies with your dad, then it sounded like it went underwater. What's going on? Movies and dinner, but then I heard tum tum tum. That's all I'm hearing. What's happening with your microphone, Ashley? Ashley, are you hearing me?
I'm hearing you in and out. My reception is poor at the moment.
Yes, it is. And I just keep hearing like a beating of a drum.
Sorry.
All right. We have to get it. Yes. I hear, can you hear me? And then I hear just a beating of a drum. So far, I hope we get a fix on that. All right. I want to know that before I begin, everybody's attentive and we are all hearing each other. All right. Raise your hand if you're hearing me quite well, Vanessa, and chat to me. Marvel Comics, like I know what that is. Ant-Man, okay. God bless when I know what the movies are. Ava, how are you? And the family?
Very good, thank you. Very good.
Okay. You have a straight face this morning. How was church yesterday?
I don't go to church on Tuesday.
Oh Lord. Oh God. You have a face that looks like somebody prayed a bad prayer for you this morning.
I'm good. Just pensive. That I'm good. That's okay. Thanks for your concern. I'm very well.
You are very well. Look well, please. Cheer up. I'm missing somebody. Roll call. I'm missing somebody. I didn't hear somebody's voice.
Tracy, did you hear Tracy?
Yes, I saw Tracy. I heard Tracy. I think it's Vanessa that what her raise your hand, Vanessa. She lower her hand. All right. Just want to know that you're there. Now, did you get a chance to go through that lecture that is there? Or go through the critical thinking exercise? The critical thinking handout. Come on, the weekend long and...
Yeah, I read the thing. I don't know if I remember a lot of it, but I did read it.
You're not required to remember it. It's always going to be there. You can always consult it. You're not required to remember everything that is there. It should be of some merit as we go along. All right. Now, today I want to go through Bruner's learning theory, go through the applications for science teaching. I want to look at Ausubel's learning theory, applications for science teaching, Gang's theory, applications for science teaching, and I want to then give some examples. Before I do that, I want us to go through an exercise. I promise that we will look at some learning styles and how you identify your learning styles. I trust that you have gone through the reading activity, gone through and looked through a revision of what we did last week, and look through what we did for constructivism, so that we don't spend too much time on constructivism, and look through Piaget's theory, and you would have started looking at the assignment, so that by the end of this week you could cover the assignment. Now, I need to take up something from over there where my notes are and see if I can go back to this OUVRLE screen and manipulate the screen. So I need to take off this headset and get up. Just give me a second. All right? I had a PowerPoint on the learning exchange, but I reviewed the PowerPoint and updated it for today's class and want to put the PowerPoint up on the on my thumb drive and I have the other things there. But the microphone is open. Hello?
Hello?
Are you hearing me, guys?
Yes.
Yes.
Okay. Are you seeing my screen?
Yes.
Yes.
Okay. Let me see what's happening. I don't know what happened a while ago. I'm trying to find the there's an exercise I want you to do in trying to find out your learning style. I wanted you to do the exercise before I did the lecture on Bruno, but I'm not locating it, and I don't want to waste too much more time. So let's go through this, and then I'll take a break and then go back to transferring it. Hope you don't mind that. Let's look quickly at Jerome Bruner's theory of learning by discovery. Are you seeing that on your screen here?
Yes.
All right. Bruner's theory of learning by discovery placed much emphasis on student-centered learning, and he underlined learning as important. The structure of discipline and mode of communication is essential to teaching, and focus learning as important at all levels. You can teach any discipline at all levels, whether the
Hello, doctor. Are you talking?
Hello? Hello?
I
We cannot hear you, sorry.
right. I know that there is something that is not working. I need to get the technician. There is something that doesn't on my screen. You hear-
Your voice is going in and out. It's like sometimes you can hear it and then sometimes you can't hear it.
there is something it same way on
Doctor, the cord is a little bit undone from the back of the computer. A
yes.
little bit undone.
We can't hear you. There's a lot of static. We're not hearing you. We're just seeing your mouth moving, but we can't hear.
Hold on. There is something that is right here. Are you hearing me now, students? I need some
It's
support.
going in and out. One time we're seeing you hearing you, the next time we're not. It's just going in and out.
Yes, and something just seems off since this technician came to be working in the lab at the same time that we're trying to have a lecture in here. This is just not right. I am so sorry.
We can't.
You can't hear.
Can anybody hear?
You can't hear me.
I heard you say that, but everything you were saying before, I couldn't hear anything.
All right. You can't hear me now.
Yeah, I hear you now, actually.
All right. Did you hear me say the process?
You just broke up again.
Yeah, you just.
You're breaking up.
All right, guys. And I'm gonna get up and get the 10. Teaching cannot take place without communication. I'm really gonna say my apologies. Where's my mic? My apologies. Take 5.
Okay.
Hello, Jason. I want to do some mic check. Can you hear me?
Yes, I hear you.
Okay. Ava, can you?
Yes, I can.
Okay. Doctor, I think we're hearing. I'm not certain. Bermuda? Who's in Bermuda? Oh, Ashley's in Bermuda. Ashley, can you hear me?
Yes.
I'm hearing Ashley. Samuel and Dominica, Samuel, you can hear me?
Yes, I can.
Well, I will stay close by to see exactly what is going on.
Hello?
Hi.
Yes, we hear you.
All right. When I try to share the screen now. Are we here?
Yes.
We're at Bruno's theory of learning by discovery.
Yes, we can see it.
Okay. On Bruno's theory of learning by discovery, the process of education, which underline his student-centered inquiry-oriented approach to teaching, are as follows. The structure of a discipline or subject and the mode of communication are essential in teaching. Content can be made appropriate for different learners' levels of understanding, dependent on the quantity of the content that is delivered at varying levels, the quality of the instruction, and the intellectual development of the child. Are you hearing the other lecturer that is delivering the course in the other room at the same time in me?
No.
Slightly.
I can hear, but it's not that bad. I can hear chatter in the background, but it's not like too invasive.
Okay, and you're hearing me better now. All right.
Yes.
Another important point of Bruno's learning theory is that very young learners can be taught scientifically important concepts in developmentally important ways. Remember, we looked at biological development and psychological development in last week. So Bruno is actually saying that yes, we have science concepts that are more complex and more abstract, but we can teach these in ways that are important dependent on the level of biological development of the learner. And he would have accepted some of what Piaget said about the level of development of the child. Third, students should be encouraged to develop the intuitive and analytical skills of scientists through the carrying out of active scientific inquiry. Now, those analytical skills and critical thinking skills which adults should have, Bruno is saying that children can be engaged in learning that allows them to think of using evidence, using science process skills, being intuitive, relying on evidence, waiting on using the evidence to prove a point. And I'll go through some of the science process skills and what they mean: being open minded, solving problems, carrying out instructions, and searching the material to find out behind some information and not taking information just at face value because an authoritative figure said it, but question things and be more engaged in active learning. So Bruno emphasized learning by discovery, that so that students can inquire into learning. We're coming up to it. To motivate students, teachers need to encourage an intrinsic interest. Intrinsic mean that it comes from within the, the students, their curiosity. Tap into the natural instinct of children to be curious. To motivate students, teachers need to encourage an intrinsic interest in a given discipline. Not necessarily only science, but since we're focusing on psychology of science, teaching and learning, the basis of Bruno's work is to encourage learning by discovery. Are we going to guide the learner so that he or she does not make mistakes, or are we going to say give instructions along the way so that we will lead them to finding the solution? That is where now the guided discovery comes about vis-a-vis the pure discovery method, where you leave the learner to explore on his or her own and make mistakes and then come to their own conclusion. Just give me a second. Now, Bruno believes that a child passes through 3 distinct stages according to his mental representation of information: enactive, iconic, and symbolic. In the enactive stage, the child uses motor responses, manipulating self-awareness and awareness of the surroundings. So the child uses his or her hand. Nice to see you, Ashley. Uses manipulatives. So it would be necessary, according to Bruno, to give the child objects to manipulate during the teaching and learning exercise. So hands-on learning would be an important part of the teaching learning process, according to Bruno, in this phase of learning by discovery. So you want to have manipulatives, you want to have objects for the child to touch and to feel. In the iconic stage, using images, diagrams, pictures, so that the child can visualize what it is that is being represented, or the teacher is talking about. So perceptions can be made real. You know, that perception becomes reality. The child is more egocentric and imaginative, and is unstable in what he or she thinks, you know, change mind very easily. In symbolic stage, the child uses language a lot, quite talkative, and mathematical symbols. So mathematics is taught and learned much easier, and there is logical reasoning, and logical reasoning develops at this more symbolic stage, and the child is more able, or the individual, not necessarily a child, is more able to draw conclusions from symbols seen, and able to make connections between the imagined and the real, and so can do some abstract thinking and some logical reasoning as this kind of thinking develops. So in science teaching and learning, Bruno is quite noted for concept and discovery learning. Are there any questions so far? Are we okay so far?
Yes, doctor. I want a clarification.
Yes.
I'm trying to follow your slide with what I have. I noticed that.
Yes. I have reviewed the lecture, so I'll change what is on the
Slide 2.
on the OUVRLE.
Okay,
Yes.
okay, doctor. I just want to sure I have the right PowerPoint.
Yes, you don't worry about it. Because
Okay,
I was distracted when I came in earlier this morning. I didn't get to hide the one that's there and upload this one, but I'll do so during the break and ensure that you have that access to this one, right? Because if you note that there are empty slides that are on the one you have, and I often prepare before my class, so I make sure that I review it, and anything that is not there, you get it, right? I'm not a perfectionist. It's just a fault. I'll try. Now, in discovery learning, there are two main forms of discovery learning. And as Tracy was asking, probably I was preempting her during the preparation. Pure discovery and guided discovery. And that word pure is used to, like Christopher Columbus, that thief who Isabella of Spain sent out said that he discovered the Caribbean 1494 or 1492 when he came out on his voyage. If you discover something, nobody saw it before you, right? I guess. But he came and saw people here. So if it's pure discovery, you don't see it. And I don't mind what Ashley is doing. I really enjoy that. Be free. You're an adult. As long as you're listening. It looked like some sushi. Not sushi though. Anyway. Two main forms. You have pure discovery, where you just set out on a voyage, not knowing exactly what it is that you are about to do, right? And you don't get any instructions from the teacher. You get materials, you might get a question, and the students are placed in groups. They might be given roles, and they are allowed to determine how they go about solving the problem or coming up with their own ideas. So the teacher creates that environment where the students just move about. The students are not prompted. The material and equipment might be present in the room, but you do not tell them what to do with them. All power is taken from you as the teacher. The students dictate the pace. They say what they are going to do. They might tell you if they feel like. At the end of the activity, they present their findings, their conclusions, and how the activity went on. And you might be saying, no, how can I say that I am teaching if I don't say something to the students? No, and how do I maintain order in the class? Am I that kind of teacher that will make the students feel that they can tear off the roof? Now, depending on the age of development of the learner and the intellectual capacity, you as a teacher will design the activity to ensure that the task at hand will allow them to discover their learning within that area. And I'll show you an activity or give you a stimulus for a pure discovery activity in a few minutes. Just a second. In guided discovery, is there somebody who raised their hand, wanted to say something?
I can't believe I keep getting booted off the site. And as soon as you started that conversation, I got booted off. I'm just coming back as you're finishing.
My God, and it was really for you. Where did you get booted off?
About 2 seconds into your talk. It's the second time I've been booted off. And then I have to go all the way back to re-signing in.
And the technician just came to do a test, All right. I was saying that there are two main forms of discovery. Did you get that?
That's, yes.
Pure discovery and guided discovery. In pure discovery, students get no guidance and are required to solve given problems like scientists. The students are, the teacher gives up the power in the classroom, and the teacher basically allows the students to explore that E, that one of those E's that we talk about, those 5 E's. The exploration comes first in the lesson at that time. They explore, and while they explore, they are learning, and the teacher, whatever questions the students ask, whatever issues that emerge throughout the lesson, the teacher allows them to engage themselves in the process and find the answers and take themselves to wherever they want to go. And at the end of the lesson, if other questions emerge and students want to go on exploring, they keep a record of it and they continue at another time, and they keep themselves engaged, and they examine, and they are facilitated by the teacher. The materials and equipment, etc., are provided for them to discover. And I was saying that in such a context, depending on the intellectual level or the level of development of the learner, the student is, the teacher designs the activity so that the level of exploration will be limited to a certain extent to the stage of development of the learner and to the content or concept that is intended in the curriculum. Is everybody still with me?
Yes.
Hopefully.
Yes.
Okay. In guided discovery, however, students might be given a general principle and are required to find a solution to a problem. They are given guidelines. They are told that at the end of the lesson, they will be expected to find the answer to a particular problem or case study, a scenario. A solution to a problem might be given. The students are required to find out the general principle on which a solution is based, which is a more inductive approach. Now, I trust that you have read the critical thinking article over the weekend and know the difference between induction and deduction. But I might just go through it a little bit more. But I said I wanted to throw to you some examples of activities that are good stimulus for discovery versus guided discovery, just to stimulate you before I give guidelines for effective use of the discovery method. So let me stop sharing this and give you another stimulus here of some I found. I stop sharing that one. Oh Lord. Okay. And fine. Are you guys still with me?
Doctor?
Yes, Samuel.
Samuel, yes. I have a question.
Yes.
I am not so clear about when it comes to questions. Because you said in pure discovery, we should not answer any questions from the students.
It's not that you should not answer. Did I say that?
No, like
I said the question leads to. I said the question leads to other questions.
Okay.
I want to give you some examples of what are you seeing on my screen. I want to give you. I got some questions or some stimulus for inquiry-based lessons. that could use as pure discovery or inquiry lessons. Just to give you examples. And this thing decided to give me trouble this morning. Why? All right, inquiry question. Let me see. Are you seeing that on my screen?
No, there's nothing there yet.
Oh, Lord. Share screen. All right. That's Bruno. Let me get this one. Are you seeing a guy with a sucking up a straw?
Yes.
All right. No. No, let's say this is a question. The question mark is not there, but this is a question. I took this from a text here, a science textbook. I need to take this and put to the side so that you can see the picture. Are you seeing the full view of this picture? Write down the question.
No.
Write down the question so that I can put. Let me see if I can make this man a little smaller so that you can see him. 150 is too big. So 125 might make him. Are you seeing him?
Yes, and the questions at the bottom, yes.
All right. Why won't the soda come up the straw? And this is a question at the beginning of a science class. And this would be vacuum. Ashley is saying vacuum. Now, if you answer like that at the beginning of the class, if this activity is at the beginning of an inquiry class, inquiry-based lesson, the student is you give this question at the beginning of an inquiry-based class. Why won't the soda come up the straw? And in introducing the lesson in the 5 E's, we would call this an engagement activity. This is the engagement part of the first E. And somebody was saying about asking a good question. Now, it is normal to pull something up a straw if there's liquid in the container, to have the liquid pull up the straw. But what makes substance flow from one space to the other? And what are the children looking at? And as the teacher, what are you preparing? What do we call this? I need you to write down this term. We call this a discrepant event. D-I-S-C-R-E-P-A-N-T. We call this a discrepant event. In an inquiry-based lesson, we call this a discrepant event.
So I have a question.
Yeah.
So I kind of come from the same place as Tracy, but I thought we were talking about pure discovery versus guided discovery.
Yes, that's what we're talking about.
But then you're saying inquiry. I thought that's not the same thing.
Yes, we're talking about the same thing, Jason. It is an inquiry-based lesson, but how do we how do we present a guided inquiry? I'm answering your question. How do we present a guided inquiry lesson compared to a pure discovery lesson?
But I thought it was guided discovery, not guided inquiry. That's what I'm saying. Isn't there a difference? Or is there? I don't really know, but.
Okay. So when you inquire, you are saying that there's a difference between, you want to know the difference between discovery and inquiry?
Basically, yeah, because I thought in the slides that we just looked at, we saw pure discovery and guided discovery, but there wasn't anything about inquiry. But now you're mentioning inquiries. I'm just trying to understand.
I'm using the words interchangeably. I just used the words interchangeably a while ago.
So does that mean that they're not different, or that's the same thing?
The word discovery is used when it is, well, I use the word discovery when I don't tell my students anything. I don't ask them any question. I design the lesson without even putting a stimulus in front of them like this. I let them discover for themselves. So, there's another activity that I will show you. There's another thing I will show you that would be discovery. But I am showing you two different things, right? I'm saying to you that in this inquiry, this is guided discovery. This one that I have up on the screen. This student is already, or this person, this is already set up, right? At the beginning of the class, at the engagement activity, in this discrepant event, I'm telling you what it is. This person is sucking at the straw. The liquid is in the bottle, and this person is sucking at the straw, and the soda won't come up. And it is happening already. This stimulus, that is what we call this. It is already there. And you say to the students, why won't the soda come up the straw? And it is the engagement activity in the lesson. And the students are going to investigate. They are going to inquire. So they are going to guess now. They are going to give you some possible answers why. Ashley just said because vacuum. As a teacher, you're going to find out why. Tell me why, Jason. Why won't it? Based on looking at that picture, why won't the soda come up the straw?
Because air is not able to enter the bottle.
Okay. Why won't the soda come up the straw, Tracy?
I thought it had something to do with pressure.
You think it has something to do with pressure? Ashley, why won't the soda come up the straw? You told me vacuum. What about vacuum?
The little seal at the top of the beverage plus the sucking out of the bottle is creating a vacuum, perhaps. Like it's
what is a vacuum?
Okay, maybe vacuum wasn't the right word. Because a vacuum is something where nothing exists, no matter exists. but trying to think of the concept, the term. There's like no displacement. Can you hear me?
I'm hearing you. I'm listening. I'm listening.
I can't remember the terms from science class way back 10 years ago.
Is there anybody who would like to help her? Tracy, would you like to help her?
I know it has something to do with the pressure on the atmospheric pressure, or pressure on the inside is higher than the pressure on the outside of the bottle because it's sealed. I don't remember.
Is there anybody else who would like to try? What causes the sucking on the straw? What does sucking on a straw produces?
Yeah, it is to do with the air pressure. That's what I mean. So like, because you suck on the straw, so the pressure in your mouth, air pressure in your mouth decreases. So air should try to enter your mouth to even out the pressure. But because the bottle is blocked, I mean, the way that the air would enter your mouth is by entering the bottle and pushing the liquid up through the straw until there's no liquid left, and then the air would enter your mouth. But because the bottle is blocked, no air can enter to equalize the pressure, so it doesn't go anywhere.
Like I said, there's no displacement.
There's no displacement. So how can we find out how to get the liquid into the boy's mouth?
How can we find out?
How could we get the liquid to go into the boy's mouth?
Remove the seal.
Okay. So what would happen if we remove the seal?
Displacement will occur.
Now, you use big terms to talk about displacement will occur, but if you take time to note what I did a while ago. First, showed you the stimulus, asked the question, right? Then you had to think about, you had to look at what is happening. You made, and I hope everybody else, Linton, Samuel, hope you're here still.
Yeah.
You observed what action I'm assuming it's a female. What action, because of the blouse and the earrings, right? What action she was doing to suck the soda up the straw. You observed that there was a seal over the mouth of the bottle, and I guided you into observing with your senses what questions you were to ask, what you were to think about. And so that those science process skills of inquiry-based learning, you took them into consideration to try to explain and carry out the investigation into how you could get the soda to come up the straw just from stimulating that discrepant event. Now, if you were to make this into a pure discovery instead of a guided discovery, so doing that the lesson that way would be guided in discovery a while ago, right? Now, the content of this lesson is about how pressure affects movement of substances, right? If I were to do this lesson by just pure discovery, I would have to leave the students to find out if the soda would come up the straw if they were to block the bottle. How could I prevent the soda from coming up the straw? Would have to ask the question a different way. Leave the students with the bottle, the soda, the straw, and say to the students, how could I prevent the soda from coming up the straw? And let them discover on their own how to stop, how to put a stopper on the bottle and prevent it from being pulled, preventing a difference in air pressure from occurring. And then write down a statement to say how a difference, how blocking the air pressure would prevent suction pressure from creating that difference to get the soda from coming up the straw. Are there any questions there? Is it any clearer? I will see if it is any clearer. Let me stop sharing and try another one.
Is it so that if someone said to compare inquiry learning to discovery learning, they're talking about pure discovery and not guided discovery?
You shouldn't think so. What do you call it now? Purist. Why would somebody want to put you in a hole?
I just think somewhere we've been asked to explain the difference. I can't remember where. So I have to find that. That's why I keep asking, because I'm like, it seems like they're too similar.
Yeah, I'm trying to find out the same thing, but I guess because it's a different term, you understand discovery, letting the children find it for themselves, but then when the terms come up, like there also is, I think it's free discovery. Also, I think I read somewhere something like that. Free discovery, open discovery, and stuff like that. So I guess you have to know the difference between the 2 or 3 or how many.
I certainly know that I'm not that pedantic, right? So to ask you the difference between those, that's not in my course. To sit down and to be thinking about you, that if you don't get it yet, it's going to take a long time coming. It's majoring in minor if it's that, not that, not at all. Now, at the beginning of a class, Mr. Simpson told a student to take up, the ping pong ball, that little light ball, like that one in the roll-on bottle. Told a student to take up that ping pong ball and funnel and go to the front of the room and try to, he told the biggest student in the class, the fattest student in the class, to go to the front of the room with this ping pong ball, the light ball, and blow it as hard as she can and see how far up in the air she could blow it. Right? And he told the slimmest girl in the class to do the same thing. But this is all that happened. and the students were to investigate why. Linton.
Yeah. Hi.
Mm-hmm. Would this be guided or discovery, or could you make this into a guided discovery or a pure discovery lesson? You can do anyone, you know, actually. You being the teacher can decide which one you want it to be. It depends on how you see your class and see yourself, I must tell you.
Okay. To me, I see it as a guided discovery.
Just ask the student to go to the front of the class and just leave them and ask them why you think it's guided discovery.
From the emotion, from what would happen there, they would be able to see that the air would keep the ball up. And then from there, I guess you would get your topic.
What do you expect to happen? That's the first thing I must ask. Now, this is something about the inquiry class that as a teacher, you must be prepared for. You must do the activity before you put it in front of the students. This is one of the reasons why a lot of teachers don't try the inquiry based or the pure discovery lesson very often, because they don't like to use the discrepant event technique of engagement very quickly. I need you all to think about what will happen and
Nothing's going to happen.
What you said, Tracy?
They can't blow it out of the funnel.
Okay, and you should be able to explain to them why. What did you expect to happen, Linton?
But you said it's the soft tennis balls, right? Like the plastic ones?
Yes, those little light tennis ball. And I
Of course
made sure to say it's a light tennis ball, and it is the biggest, fattest girl and a very finest girl, to make sure that I am asking you to make a comparison, because I expect that the students in the class would be making a comparison too. So I am waiting for all of your feedback. You're science students. This is a science activity.
This is physics.
Yes.
It has something to do with the pressure again, like this. I've seen this one. So it's like if you don't blow as hard, it actually goes higher because of it's something to do with air pressure again, like help from the physics people.
Where are the physics people? Samuel.
Yes, Samuel.
Okay, yes. Well, what comes to my mind is one is this kind of activities, as you said, the teacher need to practice, experiment it before. As Tracy said, it will depend on the initial pressure you apply. It's very important. It's like the initial pressure will affect how the ball will move. If the initial pressure is not great enough, it's just be blowing from the picture I'm seeing there. So I think it's an activity that you have to try to see whether the initial pressure, if it's large enough, and also the height of the funnel. That's also something you have to put into. So to me, is this kind of activity is something I have to try to see one, what effect will be the height of the funnel be, and how large, and what is the weight of the ball. So all that, I have to put that into consideration, because sometimes when it comes to force, the mass is very important. So what is the mass of that ball? And like I said also, the height of the funnel too, and the initial pressure that can be applied. Because I'm telling you, if you blow it,
but it doesn't matter the size of the girl. It doesn't matter the mass of the girl.
No, I mean the
mass
ball,
of the ball. The mass of the ball is the same. The ball just goes around and around in a circle. Why? That is what makes the event discrepant. The ball is not falling out of the funnel. Why?
It's the pressure and the airflow.
What is happening with the shape of the funnel and what pressure? Who else wants to try? Linton, you think you figured it out? Vanessa? Ava?
Doesn't the shape of the funnel force the air out to the side so it goes around the ball instead of coming up underneath it? So if you blow very hard initially when the ball is right sealed, then it'll lift up. But if you just blow continuously, then the ball will just spin.
And Sam and Dominica. And also, what comes to my mind is gravity.
What about gravity?
Because normally is gravity always is a force that we don't see, that always want to pull something towards us. So apart from that, gravity will have something to play, because if you try this event in Mu, you may get a different result because of gravity.
Look at how the girl's head is positioned in a straight line here, and the ball. How does gravity act? And what is the direction of the force that she's blowing? Look at her windpipe. Where is that force coming from that she's blowing? And where's the direction of force of gravity that is pushing back at the ball?
She's going up, gravity acts downwards, if I remember. Samuel?
You're right, Eva.
So what is happening as she blows up? There is an equal force that is acting down on the ball. So equal and opposite force that is acting on the ball. So will the ball ever come out of the funnel?
No, I don't think so.
No, it will not come out of the funnel. Okay, so is this a good activity to begin a class of inquiry?
No.
Why not? Will it get the students thinking?
Yes, it would. But based on your objective, maybe?
Yes, it has to be based on the objective that you set out. So you have to do good planning in order to ensure that the engagement part of the lesson, the discrepant event that you choose, is in keeping with what task you want to learn. Now, I noticed that you can get very uncomfortable with what lesson it is that you want to teach the students. Now, let's
Doctor? Doctor?
Yes.
Yes, I have a question. In either pure discovery or guided discovery, would the topic be given to the student before the exploration, or even the topic will not be given? Like the topic for the day?
No, you do not. You do not give the students the topic. That is not Bruno's theory. You do not tell the students what they are going to do. If it is pure discovery, what are you seeing on my screen?
Nothing.
Okay, let me You're still seeing the discrepant event. If it is pure discovery, you know what your objectives are, and you don't tell the students what it is that they are out to get out of the lesson, because you want them to discover it for themselves. But if it is guided discovery, you guide them, you give them the objectives. But to give them the objectives is Gaines' theory of learning, which we'll go on to next. To give them advanced organizers is Ausubel. I'm trying to now find what are the process skills that you will teach them and what those mean, to put them up on the screen for you. And all of this thing has been lost now. In the name of Jesus. Are you seeing me?
Yes, we are.
Yes.
Looking as confused as hell. And I'm not seeing the screen that I'm supposed to be seeing you. Where are you? What is on your screen? Could you tell me?
Seeing you.
Okay. Hello. Hi. Are we here?
Yes.
Yes.
All right. Is it norm for you to call all your lecturers doctor? I'm just asking. I'm just asking. I know we are all Dr. so and so, but I'm just wondering, is it norm to say doctor or just say doctor? It is irking me out, Samuel.
I think it started because we couldn't pronounce Dr.
Latibodir.
Yes, I think that's what I first noticed it happening amongst everybody.
Not me. Well, personally, I normally refer to teachers as doctor if they have a doctorate. Yeah, that's what I'm used to, like in university and stuff. That's how I did it.
Okay, I'm having a hard time getting used to it. All right, let me get used to it. Okay.
What would you prefer to? How would you prefer that we address you? I don't have a problem if you. You don't want to be called doctor. That's fine.
No, it's okay. You can just say what you're saying. I just wonder why you have to say doctor. Um,
That is just out of respect.
Yes,
Yeah.
I am understanding. No, because the students here wouldn't just say doctor and leave it at that. They would say Dr. Lee Platt or Dr. Platt, and I know what is coming next. But because he said doctor, I'm like, okay, something is happening. But it's okay. It's okay, Samuel.
Oh, I see.
All right. Let's see if we can finish this up and get you some examples. Let's see how quick we can do this. So let's look at some guidelines for effective use of the discovery method of teaching. Because Samuel, I think, just asked a question about if you should give instructions or when should you ask the questions. And here is the first guideline coming that comes to on to us here. Give your students explicit and precise instructions what they should follow. And I know if you're not a very if you're not one of those teachers who is very efficient at using inquiry to teach, which is one of the types of discovery learning, do not go for pure discovery in your beginning. Okay? If you're one of those persons who likes to have control over your class, which I suspect Samuel is based on his behavior so far, start out slowly with guided approach to discovery learning. Okay? But ensure that you give your students explicit and precise instructions. Do not make your instructions too wordy and do not have too much must do this and commanding this and that and have too many rules that you made up as the teacher, that is too teacher centered. Many of us as teachers are too controlling, and being too controlling makes the learning environment stifle curiosity. So for discovery to take place, we need to ensure that we engage the learner in an environment where they want to explore. Have materials that are available for them to explore. Provide students with adequate and relevant materials and equipment needed. So anticipate that they will need these materials for learning and you provide them, especially for smaller, younger children. So you might anticipate that they'll need more beakers, they will need some cups, they'll need colorful cups, they'll need some more dirt, they'll need to run around and walk around. You might anticipate that they'll need to sit on the floor, have the room cleaned. You might anticipate that they might throw away some of the sand, they'll throw away water. Make sure that you have parents provide clothing, protective clothing, or an apron. Go about making it enjoyable and making it fun. Provide relevant materials. Do not overburden the children with having materials that they cannot use again. Before the method is used, discuss with your students the objectives of the activities they are to perform and in the instructions they are to follow. Sometimes this is important more at the secondary level and in the adolescent stage of development, where students are not sure what they are doing the activity for or why they are doing it. So they have so much work to do that they don't have time to waste, or they feel that you're giving them too many things to do and the session will soon be up. And they want to know the reason why. So because they are at the stage of development where they want to know, why on earth am I doing so many labs? I could do this another way. There is a practical to be done and I could do it in a shorter time. But you have given me this practical before. I did this in another class. So why couldn't I do this how another teacher gave it to me? Facilitate that kind
Dr.
of,
Lin?
yes.
Okay, like I want to be sure. This guideline, is it for both pure and guided discovery?
Yes.
Or okay, because I noticed that the third point is talk about before the method is used, discuss with your student the objectives of the activities.
Where it is appropriate. Now, you see, Samuel, you with the guidelines, they are guidelines. They are not prescription to take for medicine. Okay? So where it is applicable, you use it. So I was saying as before that with pure discovery, you would not say to the students what the objectives of the activity are. But with guided discovery, you would give hints as you go along, right? But what I'm talking about, discussing with your students the objectives of the activities, not your objectives that you write in your lesson plan, you know. The objectives that you write in your lesson plan are not what you're going to disclose to the students in the way you wrote them. That is not how you teach. You are going to explain your objectives in a way that is student friendly to your students. I wrote my lesson plan for you this morning, but I did not explain my objectives to you the way I wrote them. I am sure that you know what I am here to accomplish for today, but I did not read them out to you the way I wrote them on my paper. So if you go into the lesson, for the lab talk, for example, in your inquiry, in your guided discovery lesson, let's say it's a guided inquiry, you would be explaining to the students, you would be discussing with them in the engagement part of the lesson that they will be doing an activity that will require them to find out why the air was not, no, why the soda would not come up the straw. They're going to plan and design an activity to determine why the soda did not come up the straw. So at the end of today's class, they should have a lab, they should write a report in their groups outlining the steps and the procedures. That is the discussion about the objectives that they're going to perform. In your lesson plan, you're going to write that at the end of the lesson, students, at the end of the inquiry-based lesson, students should be able to perform an activity to determine through inquiry why the substance given did not move from the soda bottle to the mouth of the other student, or students should be able to identify that suction pressure must be applied in an open mouth bottle for the substance to move from inside a bottle to the mouth of an individual. And so the objective that you write in your lesson plan must have the criteria, the content, the criteria for performance, the content that is required, and it must ensure that the student, what observable factor is there for the student measurable performance to be attained. You're not going to read that to the students. Not at all. So before the method is used, discuss with your students the objectives of the activities they are to perform and the instructions they are to follow. Give your students ample time to discuss the problems and questions that arose from their activities towards the end of the lesson. So after you leave them to investigate, to discover, to inquire into the question, you're going to have that data gathering. We are going to have that explanation phase of the lesson where you discuss the problems and the questions that they came across during the activity, where you get the feedback from them and you try to explain what happened, and then they go and expand on that. If it is a pure discovery, you have further questions that they will go and expand and research and go and do further reading about. For effective guidance and supervision, students must be divided into groups for large classes so that the discovery method is more effective. Any questions so far again?
Dr. Lee?
Yes.
Yeah. As you're talking, I was just thinking about it. I mean, for example, in my chemistry class, the only topic that comes to my mind, the pure discovery can be applied in my chemistry class is mixture. But in other topic, I think one or two students may end up taken to the hospital. Because I noticed even in my class with my instruction, students want to, like if they don't unknown chemicals, they want to put in their mouth to taste it. So I'm just imagining mixture fine, like household materials. I can try that. But in most topic in chemistry, because student, anything, they just want to taste it. So most time unknown chemicals have to be shouting, hello, you cannot put it in your mouth. You want to test unknown chemicals. So I'll be very careful to just give chemicals to students and let them do what to discover what reaction will take place or what reaction will not take place. But in mixture for sure, because it's going to be what they use, what they have in their kitchen. For them to see whether it is suspension, colloid, and all that. But in other topic in chemistry, I will not try it.
So you are starting out with a fear factor. There are many more topics in chemistry that you can try. I have one whole book of teaching science by inquiry in chemistry, but because this is not the methodology course again, I can't go through all of them, but you need to get rid of your fear and you need to learn the inquiry-based technique, and it will be more fruitful for you. Might be you're more, probably when we do the learning style test, we'll find out what kind of person you are, and might be that is what is holding you back. But there are other topics that we soon come to hear that lend themselves to application of Bruno's theory in science teaching. Solids, liquids, and gas, elements, if it's solubility, you can look at, let them draw graphs, the curves. It depends on the level of learning. What are you willing to let them explore? Cooling, melting point, boiling point, on all those things. There are a lot of things that you can explore. You probably need to teach them about safety, and they will get over wanting to taste things in the lab. Let's look at some more applications of Bruner's theory in science teaching. Bruner's theory should be applied in fact that science teaching must be student-centered, with emphasis on students' practical activities, giving them more responsibility for their learning, having open-ended investigations which promote critical thinking and problem solving. And there are some problem solving skills, and we tend to use the term problem solving in a way that is so vague and open-ended. I want to go through them after I finish going through Bruner's theory. I already told you to read through that critical thinking document. I'll go through problem solving in detail sometime, not today, but I'll just tell you the problem solving skills so that you don't just use the term problem solving as general word. What are some of the things you do when you allow students to engage in problem solving? Teachers should mark their students' science practical activities. I know this is very hard to do. Mark it in class. Go through, pass around students' desks and look at what they're doing and mark it. Mark it openly by getting feedback sometimes on what they are doing, and have a discussion in class with them on the common strengths and weaknesses, like compile them and give a feedback without saying the students' names. I know there are students who are very secretive about what was in my book and what did you see. But if you put together a list of some of the things that are common to their work, and make the rest of the class know, it helps the other students to understand that they are not the only ones who might be making that same mistake. And you treat with, as a community, those errors that they are making and that they are learning together to correct them. And then you need to go through and say, there is progress. I noticed at the beginning of the term that there was this mistake, but I notice now that this error is not being made anymore. And it gives the students a marker to make them know that they are improving on their work. Now, another thing that is important at secondary level that comes with this is that when students do well, it is very good to announce it. And this comes with the psychology of it too. So students who do a practical well, it is very good, or students who are practicing the skills of learning or a group that has done well, it is very good to applaud them or to make an announcement about it or displaying their work publicly. So you say that the student got an A, or you put it up on the notice board. Identify them, make them feel good about themselves. It boosts the ego, right? So you see that it is symbolic of their progress, right? So you praise them. So you put up the strength. So from this class, this group, or this individual strength, you make it known, especially when you give a test, etc. This is also an application, and it gives a psychological boost to the students, and it allows them to compete with each other, especially during the secondary years of schooling. Now, this works much better, according to the psychologists, in schools where you have single-sex schools. So where you have where you have all males and all females, they tend to compete against each other for the prizes. Or if you give them like a special token during devotions, recognition, and trophies. That is why trophies work so much at male schools, schools that are gender male. Trophies work more at male schools than at female schools. At female schools, they tend to like certificates. I don't know what it is about girls that like to take pictures compared to the boys don't really like to take pictures, but boys would like the vest, a vest or a jacket, and girls would prefer their picture taken with a pin, and boys would like a trophy, right? And then the prize giving. But weaknesses and strengths should be identified. Third one, some science concepts such as ecology, genetics, energy, valency, and the computer is underlining valency because it doesn't know it. The computer, you know, it's not a science computer. Acids, bases, and salts could be taught first at lower forms of the primary or secondary school and taught again in greater depths at the upper forms. So Bruner believed in a spiral curriculum. You can just imagine somebody saying to teach something like valency. How much charge? You can imagine a sulfate ion and a chloride ion. Valency of atoms. Can you really, guys, really think about this at primary school? And then greater depth at upper forms. So for spiraling the curriculum, how many of us or governments have bought into this idea of putting something like valency at the primary level? Any answers there? Do you have valency in the curriculum at primary level in Bermuda? Anybody?
Not that I know of, but they're redoing the whole curriculum this September, so I've not seen it, with the idea that they're more prepared when they get to secondary.
I could think about it talking about bases and acids, bases, and salts from the primary level because we use acids, bases, and salts every day. I can think about genetics and ecology and energy from the primary level. The valency concept is quite abstract.
Samuel?
Samuel, yes?
Yes. Well, to me is, I think energy is possible and valency is possible. All what they have to do is just at the surface of it. And when they get to the higher form, then they'll be taught deeper. To me, if in Dominica, if we want to teach valency in the lower form, all they have to know is group 1 element. Do you know them? Their valency is 1. Oh, do you know group 2 element? Can you list them? Their valency is 2. Do you know group 3 elements? Their valency is 3. And when they get to the upper form, they will know why the valency for group 1 is 1, why the valency for group 2 is 2, and valency for group 3 is 3, and 5 is 3, and 6 is 2, 7, 1. So when they get to the upper level, they will know why. But in the lower level, just for them to know the number of valency attached to each group. And when it comes to energy also, you just have to know the different forms of energy, and they can see them in picture. Then if they have any other question, maybe when they get to the upper level, then they're able to deal with that.
But the concept of valency could not be introduced at all. Just the word, it couldn't be introduced at all at the primary level, I don't think.
I'm referring to
Even
the lower level in a
no,
high
I'm
school,
saying at
secondary
the lower
school.
level, not even group, not even the concept of group of the periodic table. I wonder. Might be to show what is a periodic table, but the valency, I am wondering. I would.
They're pretty smart nowadays, so you might be able to do it with something simple like water. Because most, even in primary, they know that water is H2O. So maybe just do valency on something simple.
That water would more tell me about bonding than valency. And in order to talk about bonding, you need to know about valency. But maybe that's where me and Bruno part ways.
Maybe it's a typo. Take it out.
It's not a typo. I really read it twice. Oh, I want us to do the learning assessment before we go for break. So I want to stop. So that's Bruno. I want us to do the learning assessment before we go for break, but I need to put it up on the screen. So can I get 5? I want you to assess your learning style before we go for any further. Why are you laughing, Samuel? Tell me.
Because you said before ending of this class that I'll get to know my learning style.
Yes, because you have to go online to check. And I have one that I need you to answer the questions. I need to put it up on screen. Answer 20 questions and figure out your learning style. And before we go any further, it is not something that you have to directly do for this course, but it is a good exercise for us to understand what our students go through and what we go through. Because I need to I'm trying here to figure out how you learn. I am not sure if I'm doing all that a great job, but I'm trying. And then we have Ausubel to do and gain. And we're going to look at conceptual learning and what is a concept and this problem solving thing. Okay? So just give me 5. Okay. Are we all back? Hello? Are you hearing me?
Yes.
Okay. Okay, let's quickly. We have been saying that what we teach students at different levels might depend on their different level of, so to speak, intelligence, their intellectual ability, their the level of biological development, but also what you are taught and how you teach as a teacher can also be enhanced if you know students' learning style. How I teach you also can be more effective if I know your learning style. Now, many of us are used to teaching persons who are in front of them. Now, this is certainly not very easy. It's quite challenging for me to be teaching you and you're far away, and I am very touchy-feely. You know, I like to touch my students. I like to be in their face. So I am kind of a visual kind of learner. I know that because I have done my assessment of my own self. I like to be seeing what I am looking at and who I am dealing with. I like to know, I have to be aware of the people I am around. So from very early, I noticed that I think it was Ashley who was fascinated by the fact that I wanted to see the faces of my students. Yes, those things are quite important for me. Now, it is very important as teachers that we try to understand how we learn and how our students learn. And that's what the psychology of learning is about. How does the psychology of the learner affect how the student learns science? And I think it was important as the lecturer who teaches you psychology of science teaching and learning to go through this particular activity on, or just a little snippet on learning styles, even though it is not set out in the set out formally that I must do it. I think it is important as a lecturer to, since it is mentioned so many times in the text and so many times in the whole reading. So let's just quickly see how we can do this, right? Learning style is a combination of factors which relate to one's thinking, feelings, and physical structural endowments. Are you seeing my screen? Is everybody?
Yes.
Okay, I have uploaded this on the OUVRLE, so it is there for you. You don't have to be writing notes there. It is there. I've uploaded it and I've uploaded the everything else. These factors affect how individuals relate to their environments, including the classroom and the teacher, so on. Your preferred learning style is the way in which you learn best. The way in which you learn best. Okay, so it means that you can learn more than one way. But the way you prefer to learn is the way you learn best. You can learn other ways or different things other way, in different ways, but the way in which you learn best is your preferred learning style. So there isn't one way in which you learn, and you shouldn't think there's only one way in which a child learns something. So as a teacher, you shouldn't try to only teach one way all the time. You should vary your teaching strategy and your teaching technique, and you should also cater to the individual needs of the learner and not bore the learner. And should also understand that if one way of teaching or one strategy is not working, you can try another one. There are several different ways of classifying learning styles, and these are often done by psychologists. And in different societies, we have different kinds of classifications, and we have different psychologists coming up with different classifications, and they call them all kinds of things. But they are generally based on certain principles, and they sell them. They make money worldwide with all of these. Learning style inventories are important in the teaching and learning process, as they can help teachers to better select teaching methodologies and materials which are suitable for the varying learning styles of their students. In some countries, they invest a lot in trying to find out the learning styles of the students. You pay a big fee at the beginning of the term, and you assess your child's learning style, and the teacher gets this information and they work with it. There are different learning styles for different levels of development of the learner. And you are doing psychology of science teaching and learning. You are more aware of some of those and how those affect the learner and how to use them in your science class. However, here are some learning styles which have been identified for use. Come on, page. So we have those learners that are considered auditory. So those that learn from hearing. Those were considered visual learning style. This is generally. And those are tactile or kinesthetic learners. Those are auditory, tend to listen mainly, want to listen, and they will sit down in a lecture like this for the whole day and just listen, and they will learn a lot from just listening. Those who want to see, visual learners, and those who are tactile, kinesthetic, just want to touch and feel. Now you can take 5-minute assessment to identify your preferred learning style and receive study tips. And that link does work, but I don't want you to do that one. No, for your learning style. If you want, you have started, anybody started this one? Did anybody click on this one? There's one that I want you to do. No, that is at the end of this page. Have you brought it up on your page? Ooh. Come on, people. Come on, computer. Don't bother with me. Okay. Now, are you seeing that page for me? Are you seeing?
Yes.
All right. I want you to find out if you're a learner A or learner B by answering those questions for me. Why is my page paled out? Are you able to read it there? Are you seeing it? So all of a sudden, my page just went pale. In the name of Jesus. Why is my page gone pale?
Just click on the page itself. Click on the page.
All right. I am clicking on the page. And the page gone pale. Oh, thank you. All right. Now, answer these questions for me before we go any further. And let's figure out if you're learner A or learner B. Tick reading each statement. I need you to be able to show me your handwriting for proof. So I need you to write something so that you can hold it up to your camera. Yes, Ava. Let me see your handwriting, Samuel. You have good handwriting for a male. Let me see your handwriting, Jason. Jason, where are you? Didn't Jason come back after lunch? Or Jason went to sleep?
I'm guessing since Vanessa and I have both had problems getting kicked off, he might have been kicked off.
Whoa, I need to get the technician.
It might be a Bermuda problem. We're having a lot of rain, so it might be the internet connections. I'm not really sure why I got kicked off twice, but I know it was difficult. It said the meeting ended when I tried to get back on, so hopefully he's not having that problem.
Jason lives near me, and the telephone company was doing work on the lines down near my place, so that's why my internet wasn't working at home this morning, and I had to come here. So it may be that their work is now affecting him.
Ashley, do you have Jason's phone number? I've misplaced.
Vanessa got back on. Is Linton there? Did you get back?
I'm there. Yeah, I'm there.
Let me see your handwriting, Linton. Lord, I can't see nothing right there. It's too close.
Okay, can you see that?
Do you only write in script?
You want that? Yeah.
You only write in script?
Yes.
All right.
I guess is there internet connection not stable enough?
Okay. Jason, can you call Jason? He's in Bermuda. He got bumped off. You saw the number? Okay. You got bumped off a while ago, Jason? Did you get bumped off a while ago, Jason?
No, sometimes my computer just freezes, so I had to turn it off. It wasn't that I got kicked out of Zoom. I just had to reboot my computer.
Okay. Are you seeing the screen? We're asking you to assess your learning style.
Right, I started. I have the document downloaded. I was in the middle of doing that, and then I had shut it down.
Okay. So I'm sharing it. Are you guys seeing it? James.
Yes.
Okay.
Yes.
Okay. I wanted to see your handwriting. Show me something that you have written. How do I get this to the side?
Want it bigger again?
No, I want this to the side.
This side?
Yeah.
Just
Okay.
drag it to your bottom
No, don't want it in the way.
side. Side.
No, if it there's like in my way. Thanks. I hope I don't have to call you again. Hush. All right. All right. I wanted to see your handwriting. Hi, Jason.
You want to see my handwriting?
Yes, I wanted to see something that you're.
Differently. Well, whatever.
See something that you write on the page.
Yeah.
Hold it closer to the page, eh? I'm not seeing it clearly.
Well, when I take notes in class, I don't write very neatly. So, but.
Okay.
Yes,
It's not about being neat. See how well have you. Let's see how quickly you answer the questions. I need you to answer the questions, tick the answer to the questions, and learn A or B, so that we can go through the assessment. What kind of learner are you?
I'm not really sure about that, but.
You need to tick them so that I'll tell you how we use this inventory.
I'm not sure about some of them. But like the first two, I'm not sure. But number 3, I'm a learner B. Number 3, number 4,
You're not to do it aloud, and it's not about if you are right or wrong. It's the tick is not. It is just to say if it applies to you. Okay.
Okay.
If it applies to you most of the time. So go down in the column and tick, and then go down in the column B and tick. Count up the number of ticks you have in column A, and count up the number of ticks you have in column B for me, everybody. Ashley.
Yes.
May I see your handwriting?
Can you see?
Yes, I am seeing. I'll have exams to mark for you in the end of the term, you know.
Are you saying that we get bonus points for neat handwriting?
Well, if I can't read your scripts, I'll not be able to grade them.
This is my signature down the bottom.
What a fanciness, my dear. Hot a lotta. I see it there.
This is just like cursive, and this is print.
Yes, I see. Your lady hotness. You're one diva over there.
Oh, thank you.
And so Miss Ava is the perfectionist in the group. Let's see.
Want to see it again, my handwriting?
I'm guessing from your handwriting.
You're a psychologist, so.
Let me see. let me see. Has everybody finished just how you make those letters? They're quite curvy. Who is not finished?
I think we all done.
All right. Now, if you have more statements in A than in B, let me see. Who has more statements? Who ticked more statements in A than in B? Who ticked more statements in A than in B? Jason, did you tick more statements in A than you ticked in B?
No. More in B.
You tick more statements in B?
Yes. Not much more, but one more. So yeah, B.
One more statement in B than in A?
Yes.
Mm. How many statements in B than in A did you tick, Samuel? Where is Samuel?
Oh, yeah.
How many more statements in B than in A did you take? Five?
Free.
Ashley is saying that she ticked 9 statements in A. Is that what you're saying, Ashley? 9 statements.
One in A, 9 in B.
1 in A, 9 in B. 1 in A, 9 in B. Let me hear. So I'll tell you what that means for my class. What about Tracy? How many more statements in B than in A?
I got 7 and 7.
You have 7 and 7. Interesting.
Only one per number.
Yes. Hello?
Like per row, we tick either one or the other.
No, you don't have to tick one or the other. They don't really compare. Huh?
Oh, okay. I have to redo column A then.
Yeah, that's interesting. I didn't realize that either.
What did you do? Compare. You did a cross?
I think either one
like,
from A to B.
Like which one is more like myself. So for one in A and one in B, which one would I pick? So I'll go with B or A.
Your thinking is interesting. So the next time I do this exercise, that informs me that I should remove the grid lines. Because might be my students think that they should compare them because they're in different rows. They're different columns, but the rows are aligned to each other. I wonder if it will take the changes now. I didn't PDF this document. My God, help me and you guys. Why did you think that? Why did you think you needed to compare? I have poor handwriting which frequently asks people to repeat what was said.
I wasn't sure about it, but I decided because the statements weren't, they didn't pair up. They were about different things, that you actually just wanted us to tick whichever ones applied to us and not one or the other.
So why did you keep quiet instead of asking me a question?
Because I made up my own mind about it.
Do I scare you that you wouldn't ask me? These statements don't compare. There are two different types of learners. If you have more statements, if you have ticked more statements in A than in B, you are likely to be an auditory learner. If you tick more statements in A than in B, you are likely to be an auditory learner. Okay? If you tick more statements in B than in A, you're likely to be a visual learner. If you tick equal amount of statements on A and B, or close, very close, you're likely to be a kinesthetic learner. So I think I have in my class more visual learners than auditory learners. So I'm wondering how this talking to you will work out. My internet connection is unstable. Are you hearing me?
Yes, I hear you. I have my mic on.
I am getting a message on the computer screen that's saying my internet connection is unstable. Are you hearing me? Are you guys hearing me?
Yes.
Yeah, hear you.
Hear you clearly.
Okay. So it would seem to me like we need a more detailed learning inventory in order to find out what is your learning style. But in general, I have more visual learners, it would seem, in the class, and that would require that you need to see more things in order to make that connection between what I am saying and what you are hearing and thinking, and to pay attention, right? But as adults, there are other ways that psychologists classify your learning. So let me go back up. Are you still seeing the screen? As I'm still getting this message that's saying, there's a message on my screen. Things are a little funny today. I just feel funny from this person came in to talk about fixing some things here, right? And we can make assessment about preferred learning styles. And I actually did these, and the links are there. So you can try the links for yourself on your own, right? howtostudy.com. This link does work. You can follow this link and assess your learning style. It works right away. There are 20 questions here on this link. And this one is a British link that assesses your learning style. And this one has a cost, £20 cost to assess the learning style, and a quiz. And some of these learning style inventories and assessment are also extended to help the people in the workplace to understand the learning style or the work style or ethic of their workers, because you know that while you're in the workplace, you can learn things, and there are some people who need to learn how to think while they're at work. And the bosses, the HRs, they use these learning styles to help their workers to perform better. So there's a classification of thinkers and learning styles that also helps to prepare people. I often use this classification similar way that the British use, because we are influenced by the British curriculum in the Caribbean. Many of our colonies were occupied or colonized by the British. So we talk about different type of people and learning styles, and our curriculum were influenced by the British. So I often tend to look at the British way of doing things. And so reflecting on the curriculum. So here I have outlined their classification, another psychologist, set of psychologists, learning style. And the link is there for you to read further, but just some of what I have taken out. For the adults, so to speak. Now, you might classify yourself as a reflective thinker. We have some reflectors. As an adult, I know that the children you would probably use the learning style classification as the auditory, the visual, and the kinesthetic or the tactile learner. But let's talk about the adult now. What kind of learner are you? Are you a reflector or a reflective thinker? Do you prefer to observe and process information before drawing conclusions and offering an opinion? Reflectors need to work thoroughly at their own pace. Are you that kind of person? Reflectors like to stand back and look at a situation from different perspectives. They like to collect data and think about it carefully before coming to any conclusions. They enjoy observing others and will listen to their views before offering their own. I see some of you in this class. I think I see 2 persons who are like this in this class. Linton, are you there?
I'm there.
Okay. I think Linton is a reflector. Reflectors learn best when observing individuals or groups at work. They have the opportunity to review what has happened and think about what they have learned, producing analyses and reports, doing tasks without tight deadlines. All right? These persons don't like to do certain things. You need to know these things about persons who are reflectors. So soon this type of person is going to ask me, when is the assignment due? Or when am I going to get the assignment? Reflectors learn less when acting as leaders or role playing in front of others. This type of person doesn't like to be the leader in the group at all. Reflectors learn less when doing things with no time to prepare. They don't like to be put on the spot at all. Don't like to be thrown in at the deep end or being rushed or worried by deadlines. So, to assess if you are a reflector, you might want to check out this group here. Might be I'm wrong, Linton.
No problem. I see if I smile.
We have the theorists, and I think Samuel is one. Methodical, rational, and analytical. Usually perfectionists who are good at remaining objective. They need a clear objective and work best with structure. Theorists adapt and integrate observations into complex and logically sound theories. They think problems through in a step-by-step way. They tend to be perfectionists who like to fit things into a rational scheme. They tend to be detached and analytical rather than subjective or emotive in their thinking. Right, Samuel?
I think I'm seeing more of reflective and theorist. So both of them, I
Fine.
can link them together.
All right. Theorists learn best when they are put in complex situations where they have to use their skills and knowledge. They are structured in situations with clear purpose. They are offered interesting ideas or concepts even though they are not immediately relevant. They have the chance to question and probe ideas behind things. Theorists learn less when they have to participate in situations which emphasize emotion and feelings. Theorists learn less when the activity is unstructured or briefing is poor. Theorists learn less when they have to do things without knowing the principles or concepts involved. Tracy is somewhat like this. Theorists learn less when they feel they're out of tune with the other participants. Example, with people of very different learning styles. The activists. This sounds like Ava. Activists enjoy new experiences with enthusiasm and an open mind. They are great at thinking of new ideas and leading people. Activists like to be involved in new experiences. They are open-minded and enthusiastic about new ideas, but get bored with implementation. They enjoy doing things and tend to act first and consider the implications afterwards. They like working with others, but tend to hog the limelight. Activists learn best when involved in new experiences, problems, and opportunities. Working with others in business, games, team tasks, role-playing. Being thrown in the deep end with a difficult task is a pleasure for an activist to make sure that they conquer it. Chairing meetings and leading discussions is something that thrills the activist. Activists learn less when listening to lectures or long explanations. And activists learn less when reading, writing, or thinking on their own. They learn less when absorbing and understanding data and following precise instructions to the letter. They learn less. Who is laughing? I hear Ava laughing. Pragmatists.
Sorry, guys, sorry.
Ashley, girl, and Vanessa, these two people can fit into any situation and make it work. They are practical and enjoy trying new things. Need to recognize obvious benefits to be happy doing something and do not enjoy theory. Pragmatists are keen to try things out. They want concepts that can be applied to their job. They tend to be impatient with lengthy discussions and are practical and down to earth. It lost connection a while ago. Yeah. Sorry, it just came back. Hello?
You were only gone for a few seconds.
Okay, I was gone. It has lost. Okay. I was, where was I? I was at, I need to share it again.
Pragmatists.
The pragmatists. Pragmatists? Okay. These pragmatists are practical and enjoy trying new things. Need to recognize obvious benefits of doing something. No, everything just went. Okay. The pragmatists, they are practical. They must see the function of something in order to learn it or to want to do it. Need to recognize obvious benefits to be happy doing something and do not enjoy theory. They do not enjoy things being theoretical at all. Pragmatists are keen to try things out. They want concepts that can be applied to their job. They tend to be impatient with lengthy discussions and are practical and down to earth. Does this sound like any of you? Hello?
Yes.
Mm-hmm. Where are we on the TV? I must call this thing TV now because it's not moving out thing now. All right. Pragmatists learn best when there is an obvious link between the topic and the job or the task at hand. They learn best when they have the chance to try out techniques with feedback. Example, role playing. So in the classroom, you'll have to give these persons something to do instead of us sitting down here and, talking about inquiry. We have to go do some inquiry, right? They are shown techniques with obvious advantages. Example, how these can save them time, or how these techniques can let them teach better. How can this technique make me write my lesson plan? You're telling me about inquiry. How can it help me to write this lesson plan? I just don't want to hear about it. I need to be able to write the objectives. I'm sure somebody is saying that to me. They are shown a model they can copy. Example, this is saying a film or a respected boss in the workplace, or they are shown a teacher teaching inquiry or teaching by discovery. I am hearing that echoing in Tracy's mind. She wants to see an inquiry lesson or something by discovery. I might just get a chance to teach one. I don't know. Pragmatists learn less when there is no obvious or immediate benefit. But I don't think it's my responsibility to teach anything in this course. I am to teach you how to identify through psychology what are the thinking, what kind of thinking is going through. If I go and do that, I might not finish the course. That's what I'm worried about. They are shown a model they can copy, right? Pragmatists learn less when there is no obvious or immediate benefit that they can recognize. I soon get to go, Jason, right? You can go get some lunch. I see you have something to eat. You soon get something to eat. You hear, Jason? Right? I am hungry too.
Yeah.
Mm-hmm. There is no obvious or immediate benefit that they can recognize. If pragmatists don't see any immediate benefit, there is a problem. If there is no practice or guideline on how to do it, there is no apparent payback to the learning, then, and it's all theory, pragmatists do not enjoy that. Okay? So that is it. Any questions before we take the lunch break? And I see somebody going to say, don't ask no question, we're hungry. Are there any questions before we take the lunch break? When we come back from the lunch break, we'll do awesome. When we come back from the lunch break, we look at Ausubel and GAIN and their application to teaching and learning. Right? And then we start looking at what is a concept so that we can go into conceptual learning. Okay? So we come back in the next 30 minutes or so. Right?
Okay, thank you.
All right.
Okay, bye.
Hello?
Hello.
Yes.
Hello.
Yes. Good afternoon. Are you there?
Good afternoon.
Good afternoon. I just need you to look in your course reader. The question that was asked at the beginning of the lecture is still puzzling me, and I went into the course reader just to point out and just wanting to make sure that we look through and see about this discovery and this inquiry approach to learning. Just read some more and just look at what the different perspectives are. Look at page 11 in the course reader here. Is Ava back? I think we've gone more than the 30 minutes. Ava, Ashley, Tracy, Vanessa.
Yes, I'm here. Sorry, I'm here.
Okay, Ashley, Vanessa, Linton. I see Linton, Samuel, Vanessa.
Vanessa here.
I'm here.
Just on page 11, just to point out something you need to take note of. Just to look here under what is in the reader, under Bruno. Oh, where am I? Jerome Bruno. In science teaching and learning, Bruno is noted for his advocacy of concept and discovery learning. He notes that through discovery learning, students will become intellectually potent. Discovery involves the search for knowledge. Bruno proposed that through discovery learning, students will begin to realize that patterns and regularities exist and that they can be independently discovered. Karin, 1989, identifies four advantages of discovery teaching outlined by Bruno. Intellectual potency, the development of the mind as it is used in the discovery process. Intrinsic motivation, increased self-motivation. Learning how to investigate, that is how to find out. Improved memory and application of ideas. Gale, 2001, notes that Bruno believes that the student should become an active participant in the educational process. That is the student-centeredness that I was talking about. Discovery learning contrasts with the expository approach to teaching, which is more teacher-centered and less activity-oriented. We already went through that. But what I want to note here is discovery is the process by which a learner uses the mind in logical and mathematical ways to organize and internalize concepts and principles of the world. That is general definition of discovery there. The following four elements of guided discovery were also identified by Karin. An invitation to learn, then exploration and discoveries, proposing exploration and solutions, and then taking action. That is what happens generally in the guided discovery lesson. In science teaching, these four elements are advantageous for the development of science process skills, attitudes, and content. Invitation to learn involves catering to the learner's needs, arousing interest, developing their curiosity, and maintaining attention through the use of visuals, sounds, or other materials relevant to the topic. And notice the materials must be relevant to the topic. I need you to highlight in that part of I need you to highlight that part up to there of the reader. I know the Rose curriculum wouldn't be applicable to you, the persons in the the course here, because the Rose curriculum is applicable to the Jamaican context. Which part of the curriculum it would be applicable to you in your country, you would need to find that information. And by Friday, I would be giving you your assignment so that you would know exactly which topics outline in the curriculum, etc. So you can pay attention to that. But so that you can note where you can provide guidance and identify some topics in the curriculum where you can use discovery learning, etc. But go down here. You see, are you seeing where my cursor is? Free discovery occurs when students plan, and that is what we're talking about, the distinction. Tracy, are you with me? Tracy?
Yep.
Okay.
Yes, I'm with you.
Okay, free discovery occurs when students plan and design their own practical activities or design their own projects. In these cases, they may be expected to identify their area of interest and specific problems. Such skills are usually developed during the planning and designing of experiments, right? And we already looked at guided discovery or guided inquiry. But what are the process skills? I'll soon look at some of the process skills in detail coming. In inquiry teaching, the term inquiry teaching is sometimes associated with discovery learning. In inquiry-based learning, the study is directed by students' questions and interests. Ejen and Kokchak identify the following steps for inquiry. So in an inquiry lesson, these are the steps. Identification of question or a problem, formulating hypothesis, data gathering to test the hypothesis, making conclusions based on data and the results, using conclusions to make generalizations. So the teacher would guide the lesson through these steps to make it inquiry teaching. So it would start with a question or a problem. And then the students formulate the hypothesis. Whatever guidance the teacher provides would let them come up with a statement that shows the relationship between two or more variables which can be tested. That is formulating the hypothesis. They would gather data to test their hypothesis. And while they gather data, they are going to make conclusions about this based on the data that they collect, the evidence that they draw, and using conclusions to make generalizations from the data. Are there any questions there? Right? I hope that makes it a little clearer about the distinction between inquiry-based learning. So I'm sure this reader is available to you, and there is a little summary here for
I see it. Can I ask a question? Sorry.
You are always welcome to ask a question.
Okay. I understand the differences. The question is, in terms of free discovery, would it actually follow a curriculum per se. Because you remember you have to, before the term starts, you'll have to have your plan, and then you'll say X, Y, and Z. But based on what I've read in free discoveries, like the children just go in and do their own thing and they discover what else. Is there a structure in free discovery? Because I'm not getting that, or I'm probably missing it.
I would like to understand what you mean by if it would follow the curriculum.
Okay.
What is in the curriculum? The curriculum is a guide, isn't it? Let's say in the curriculum, you have that the students should learn the concept of Archimedes' principle, you know, like buoyancy, why objects float or sink, and upthrust and so on. And you want to teach the students by, you can choose as the teacher to let the students learn this. This is a grade, let's say 3 class with students that are what age now? For grade 3 would be 8-year-old, and you have pure discovery, and you want them to use Archimedes' principle, right? And you decide that you have put in front of them a container with volume of water, with a certain volume of water, and you say to them which objects will, you don't say to them which objects will float or sink, but in the curriculum you have to teach them why an object will float or sink. And you have these concepts and you want them to learn it. It's a part of the curriculum, and you're going to use free discovery learning. At the end of the lesson, they should learn a particular concept. They should learn Archimedes' principle. You are not going to tell them at the beginning of the lesson that they are going to learn Archimedes' principle and learn why an object floats or sinks, but you're going to provide the materials for them to explore the different objects, if they will float or sink. Based on your experience as the adult and as the teacher, you're going to provide objects that are large, small, heavy, light, shape, irregular, found different places, or you don't provide any objects at all. If it is pure discovery, you let them try to discover which objects would float or sink. They tell you which objects they would want to figure out if they float or sink, and then you let them research what ideas they come up with. You don't tell them why objects float or sink until they discover that a streamline shaped object, or that if the upthrust affect if the volume of liquid in the container is a certain amount, some principle, and they discover it themselves, or you could guide them by doing a demonstration and then asking the questions that will guide them into discovering what is the Archimedes principle, and by letting them guess which objects would float and which objects would sink. Ava, where are you?
I'm multitasking, but I got it now. It's clear. I got it.
What did you get?
I get the free discovery is not letting the students just do what they want. You have your objective, but it's the way you go about it. Let the children come up with it themselves, and then you tie it into what they're supposed to learn. I get it.
Okay. Okay, so we are supposed to move to, are there any other question? Your reader has in Ausubel and Gain, right? But I have on my, so where you can do free, further reading. Here, right? So I'll stop sharing this and we go back to the PowerPoint. I just wanted to see if that would make it any clearer. Is it any clearer now, Tracy?
Yes.
Okay. So before lunch, we looked at, or before your lunch, I haven't had lunch yet. Hope I don't get cranky. So we need to look at, are you seeing my screen now? Ausubel's verbal learning model.
Yes.
Okay. Is it too fine or are you seeing it clearly? Did you find it on your OUR-VLE? No. I uploaded it. I uploaded it on the learning space now. So you should be able to find it there to be able to follow. So he's David Ausubel, hope I'm pronouncing his name correctly, assumes that learning occurs through the cognitive structures of the learner. And I have this in italics. And he's the one that emphasizes that the single most important factor influence learning is what the learner already knows. So when you write lesson plans and prepare for teaching and learning, this is the person that influences the writing of the lesson plan, that involves you having to find out what is the prerequisite knowledge of the learner. You often hear someone asking you, what is the prerequisite knowledge? What knowledge does the learner come with? What is it that the learner knows about a particular topic, a particular concept which you are about to teach? Every time you're about to present a concept and the content of a lesson, you start to think about, or you should start to think about, what does the learner already know? When we met Piaget, he spoke about the schema. How are you going to scaffold the learner into unmasking, into learning this new topic, in this new idea? This is where Ausubel verbal learning model comes into place now. How am I going to let this learner meaningfully understand, meaningfully learn what I am about to impart or try to impart, so that the learner can incorporate new ideas under general ideas already in memory? When a learner incorporates new ideas under general ideas that are already in memory, we call this subsumption, subsume learning. Notice that whenever we see something for the first time, we try to ensure that we equate it, or we try to make it equivalent to, or try to say, okay, what does this look like? We try to file it into context of what we already know. Now, a similar process occurs in order for a student, for an individual to learn. We incorporate new ideas into a general scheme, a general what we already know. Okay? Under Ausubel's theory of verbal learning, he makes a distinction between meaningful learning and rote learning. And in science, this is very important for us to understand if the learner is meaningfully learning something or just parroting information. You know, when we go to a class and we have learned something meaningfully, we know the difference in our thinking, in our head. If you just went through the motion and just can repeat or just swap the information and write it down word for word, and you did not assimilate, I'm sure you learned that word by now, the knowledge, you know the difference. What is meaningful learning, according to Ausubel, is meaningful learning takes place when the concept and material to be learned have potential meaning. As a teacher, how can you make this concept and material to be learned have potential meaning to the students that you are teaching? So you have learners that you know they are visual learners, or they are auditory learners, or they are kinesthetic learners. What type of learners do you have in front of you? They are practical learners. How can I make this concept or this material that is in science more meaningful for them to want to learn it? That is about making learning more meaningful. The next important concept for under meaningful learning. Meaningful learning takes place when the learner possesses relevant prior concept knowledge to anchor new ideas. Now, if when you begin the lesson and in the engagement phase of the lesson, the students do not find the engagement phase or the inquiry relevant, or what prior knowledge they got at primary level is not relevant to what they are learning at secondary level, then their secondary level of education is not going to be meaningful to what they learned at the primary level, because you have to build on knowledge. So after we spoke about Bruno earlier, and we talk about the spiral curriculum, that you can learn anything at one level based on how you put the content. But if the content was not relevant to what they are learning at the secondary level, that prior knowledge that they had at that primary level, when you get that student at the secondary level, you cannot anchor this new concept that you need to build on at the secondary level. As again, according to Ausubel, the single most important factor influencing learning is what the learner already knows. So you are going to say to yourself as a teacher, what is going to influence if these students learn this concept at this level, at grade 7? Did these students learn this particular concept at grade 7, at grade 6? What do these students know? So you look in their curriculum and you figure out what prior knowledge do these students have, or what should these students know? What am I going to anchor the knowledge on, the learning on? And third thing, for meaningful learning to take place, she or he must freely decide to incorporate new knowledge in ways that are non-arbitrary or non-verbatim. You cannot force people to learn if they are if they make up their mind that they're not going to learn this course, if they're not ready to learn, if you don't want to do this course, if you don't feel like you want to do this, or you don't want to go and study, you cannot force water uphill. It might turn, well, you can force it uphill if you buy a pump, but it's going to cost you a lot of money. But people will go through a lot to try to incorporate knowledge, but it will be just by rote learning. No, it is rote learning if none of these three things take place. Are there any questions so far about Ausubel's verbal learning? Any of you want to tell me how you incorporate this? I think I hear Tracy's mic. Any questions so far? Hello?
No questions from me. That's even.
No questions from me, Tracy.
Okay. All right. Let's move to applications of Ausubel theory in science teaching. Now, this is where direct teaching through instruction and traditional teaching methods are useful. The teacher must know his or her content. So, you must prepare the content, must prepare to have knowledge to impart to the students in the lesson in order to make very good use of verbal theory of learning, to make learning meaningful. Your students have to trust you and trust that you know what you're saying when you say it. And you say things in a logical way, and that when you say something, they can trust that you know, you're prepared to engage them, and they can find the information that you're saying to them useful, that they will want to learn it in a meaningful way. For students to want to listen and to take the content, a large volume of information that you have to say to them as meaningful, to store it in their long-term memory, whether you give them by lectures or in a book or in note form, they have to trust you and trust your judgment, how you give it to them. So some form of traditional didactic approach to teaching must take place. And this occurs because there is an application of this type of verbal learning. So the teacher must talk and communicate content in the science classroom, part of the application of Ausubel's theory in science. So somehow you can't get away from handouts and diagrams and what now, concept map, and the information must be accurate. A science teacher must pass on accurate information. The teacher should have accurate and current knowledge of concepts, right, that you plan to teach. It must be written out in a logical, systematic way, because science is the systematic, organized study of nature. And when we look at concept learning after this, in the next lesson, right, on Friday, you will understand why it is important that you should, as a science teacher, teach accurate and current knowledge and keep yourself current. Because you see, once you teach something wrong, heaven help us, Lord. To take another application of Ausubel's theory in science is to take account of students' intellectual readiness for meaningful learning to ensure that fairly simple science concepts are first taught before complex ones. So you need to be able to evaluate the level at which your students are at, evaluate their learning styles, evaluate if they understand simple concepts by clearly asking questions, reviewing the curriculum, reviewing their level, the level at which they are, and then understanding where you should pitch your lesson. What is their prior knowledge? What am I going to anchor that lesson on? And then you move from there. Start lessons using advanced organizers or introductory questions and activities to ascertain the correct ideas and alternative conceptions students have on a given topic and decide on appropriate teaching strategies. Now, this is something that we'll have to go through in more detail in conceptual learning and how to look at what are alternative conceptions. I know that you are not off it with this term alternative conceptions. We'll soon get there. But to start lessons with advanced organizers is to ensure that you say to students, this is where we are going. Sometimes it is very good to lead students into saying, these are the tasks that we expect to get done. So you tell them of the expectations so that they will be prepared to work at a pace and they will feel accomplished at the end of the day. Okay? And give them an idea of the objectives of the lesson. If they are adults, you might be able to give them advanced organizers like how I give you readers, a reader, you get the course outline and so on. So you can be on your own and you're not too much of a baby. Are there any questions so far? Other applications of Ausubel's theory in science teaching: teach students to construct concept maps and V diagrams, and we'll have to do this in detail, I must tell you. So by Friday, we should be talking about what is a concept. If I don't get there today, I don't think I'll get there today. What is a concept and how we draw concept map and V diagrams that they will use as advanced organizers at the beginning of lessons or as alternative assessment tools towards the end of some lessons. So we have to look at concept maps and how we construct concept maps in detail. Use student-centered instructional strategies so that students can participate actively during lessons. That's another application of Ausubel's theory. I have a feeling that somebody gave you an assignment and what I am doing is something to do with them and not me. Keep summarizing the lesson as you go along the board for you to apply Ausubel's theory, what the child already know. So when you put what you teach, like on the board, what you have taught or what is the essence of a particular topic on the board in a corner, the students will have a visual picture of what are the salient points to take away from the lesson. At the end of the lesson, especially a science lesson, you should have a summary of the lesson. You see, just like how in the reader, you have a summary at the end of every session or every day. It is a good way to keep track of what you should have learned at each session. Is that okay so far? Is everybody fine now? Are there any questions so far? Let's look at some people say Gagny, I say Gain. Because that I learned that he's a Frenchman. Gang. Robert Gang. Learning hierarchy. Any questions so far? Hello? You know how many things Ava did since we are here? the multitasker. Anyway, no problem. Gain behavior learning model. Learning hierarchy is based upon the notion that all learning must proceed from the simple to the more complex in well-defined stages. And, you know, like sequence this through the curriculum. And that this is where we have this great influence more than anything else. Each step of the evolving content or skill is to be defined by careful examination of the entire learning sequence. And so there are some things that are taught at basic school that not taught at until you reach primary school, and you teach from more simple to more complex skills. So like reading must be taught first, because reading is taught to be the gateway to all learning. And mathematics skills are taught first as the first science, because without mathematics skills, you can't do the other science skills, right? And so on. Each step of the evolving content or skill is to be defined by careful examination of the entire learning sequence. Based on Gaines' theory, the learner's prior knowledge will determine what further learning may take place. So if the children are unable to read, then they don't move them to another level. If they are unable to carry out certain mathematical tasks, they don't move them to the next level either. In science teaching, it is important that the meaningfulness of the materials to be used in science instruction progress from concrete to abstract ones to enhance learning of process skills. And I cannot emphasize that enough. We need to often start with concrete things. And I have this challenge, especially with the people who are in chemistry, who love to start with matter and particulate nature of matter, and like to talk about atoms. And no matter how the research shows them that matter is so abstract a concept, and atoms and valency is so abstract, let us start with talking about solids, liquids, and gases, and talk about substances first in the curriculum. They say, no, how can we talk about substances before we talk about atoms? We need to talk about atoms. And then when they jump into the deep end of these abstract concepts, and the students still do poorly at the CSEC level, the scientists, they come back down and say, wonder why I taught my heart out and the students didn't learn. We can teach the same concepts if we move from concrete to abstract ideas and get more fruitful results, be more successful. There are several persons who have done it and they still finish the syllabus. It still works. I remember teaching at my first experience teaching was teaching chemistry. And the other day I saw my students put up my picture on Facebook and say, this teacher was a very good chemistry teacher. She dared to start the syllabus at solids, liquids, and gases when the other teacher was teaching us about matter. And we were wondering what matter is, if matter was something in our eye. You know? Just the prior learning experiences of the children and what this atom is, if it is something out of space. We need to condition ourselves or try something new. Application of Gain learning theory in science teaching include organize the materials to be learned orderly and present them sequentially and hierarchically. The science teacher needs to determine the body of knowledge on a concept or topic expected to be learned at the end of a particular lesson. You need to spend a lot of time in preparation to be successful. quite important. And think about what is a concept and what is a complex concept and what is concrete versus what is abstract, and how to bring the concept across, and what are the different type of learners in your class. How do I ensure that I'm catering to their different abilities and their different needs? The teacher should then administer a pre-test on the hierarchy of learning tasks identified on the concept to determine the prerequisite concepts the students have mastered and the parts of the hierarchy where they will start learning. Where would you start the lesson? Where would the engagement phase of the lesson begin? That is something that is very important on which they would anchor. So the best science teacher now, so we are going back to where we started in the first class, would be able to put several learning theories together and use several applications of these learning theories. And when this, at the end of it, apply those learning theories, plus remember, teaching is an art and a science. Remember, we said that at the beginning of the course. You know, we said that we emphasize that teaching is an art and a science, right? And when we finish teaching science, we want the students to become critical thinkers. We want them to become scientists. So we have to bear all of these things in mind. And when we teach science, they are going to have the knowledge, the skills, and the attitudes of scientists. Let's look at some of the primary process skills before we run out of time, just quickly, because I recall saying that I make sure. And some of the activities. Are you seeing that screen?
Yes.
Yes, yeah.
Okay. These are basic, right? I didn't get to scan the problem solving skills, which I am going to make sure I share before I leave here. I'm looking at just read through quick. I uploaded in a folder on the on OU VRLE. I uploaded some inquiry, some materials, and I think I uploaded this in the folder on the page, and I uploaded gains levels of hierarchy in that folder. Gain learning levels in the folder. Have you looked? Let me just look at this, and then I think let me see if I can show you gains level. I hope I have them. Gain learning levels. I uploaded them, I think, in the folder. Level 1 signal learning. If anybody download the folder, you will see them there. If it's not yet in it, I will have to put it in there. I'm sure I uploaded it over your lunch break. Signal learning, stimulus response chaining, verbal learning, level 4, and level 5, concept and multiple discrimination learning, level 6, concept learning, level 7, principle learning, level 8, problem solving. Have you found this in the folder? Primary process skills in the folder?
Is it a folder that says inquiry/discovery learning stimuli?
Yes.
Okay. I'm not sure what's in those documents. I have to look still.
Gains hierarchy should be in that folder. If I have not put it in, I'll put it in. The 8 learning levels for gain.
No, I don't think it's in there. I could be wrong, but I don't see it in here.
All right. Let's look at. All right. Before I look at this, I'll just tell you. I have it on either the thumb drive or put it on a different thing there. That there are 8 levels for gain, right? Yeah, we have level 1 where signal learning. So I have a table that I will upload for you, right? But there's a lecture right after this, so I'll upload it when I get out. Where involuntary actions related to emotions and fright. Students are quite emotional. And then there's level 2 where you have stimulus response, where teacher say words and students want to repeat it. Then we have level 3 where we have chaining. So you let the students write and they trace words, like you mark words and letters and they chain. Or chain behavior. You can teach them to thread a needle or tie shoes lace. And then you have level 4, verbal chaining. So you can get them to recite a poem or sing a song and follow words. They have verbal, so level 4, verbal chaining. Level 5, multiple discrimination learning. Level 6, concept learning. Level 7, principle learning, and we have problem solving. So I'll put that up for you, and we could get to go through it at the beginning of next class. Just if it is not on the slide for me to show you, then don't worry about it. The main process skills, science process skills here, observing, this one. And observing does not necessarily only mean with the eyes. You can observe with other senses. So describing properties of objects, systems, and living organisms, the texture, the color, the smell, the shape, the size. Classifying, measuring, communicating, inferring, predicting. You see them all here, recognizing space-time relations, recognizing number relations. And you see the descriptions there. You see this article there in your in your folder?
No.
Okay. All right. Now that I have bored you all to death today, I need you to tell me one thing you did not like about today's class and one thing you liked about today's class before we end today's class. This is Bruno. So I need to hear what you didn't like before we end, and one thing you don't like, and then one thing you learned. So there are three things you need to each tell me. One thing you learned, one thing you didn't like, and one thing you liked. You sound like you're speaking Spanish. Let me fix my headset. Yes, Linton. I think I need pen. Or if you have a question, I need pen. Because I do make notes. Yes, thanks. Yes.
Okay.
Yes.
Okay, well, class was okay, it was engaging. And one thing that I learned, well, actually learning processes, make sure that we started from simple to complex. We were able to raise our awareness of concrete, abstract, the types of learners, catering to the abilities of the needs of students, get into the prerequisites of the lesson. Well, what I did not, well, not did not like, but it was good, a little break through the lesson. It was okay, it came in handy.
Okay. Thank you. Okay, who is next? Who wants to be next?
I'll go next. I guess one thing that I learned was the learning styles for adults. I'd never heard of those before. Reflective versus, what was it? Pragmatist and theoretician or something. I don't know.
Theorist.
Theorist. I can remember, but yeah. That was something I learned. And
Which one are you? Which one are you?
I'm not sure.
Which one you remember most?
I guess the reflective and the pragmatist.
Okay. All right.
Then other than part that I struggle with was discovery versus inquiry. I still don't really understand the difference, but I'll be trying to do some reading on that, I guess. I also had a question, but this is related to the assignment. A question, this is more related to the assignment you said we discussed on Friday relating to curriculum. I just kind of wanted to know, are we going to need to find out what the curriculum is here in Bermuda? Because we might, at least I don't know how easy to access that information.
No, this is not a course about the curriculum, so I not ask you that. And
okay.
I have been trying to take up, because questions like those are asked because students want to know what kind of questions come on an exam, like this course. And I took up questions for, like past questions and assignment to share with you guys. I am trying to see if I can find them as we speak so that I could read one or two of those questions, but I'll make sure that I have them for Friday so that, okay, I found it here, so that you can stop worrying about what you shouldn't worry about. You don't get paid to write questions, or mark them. I don't see why you worry. I know you are the ones doing the exam, but I'll read what? I'll read some of the questions after you. I'll read one question for you so that you get an idea. Nobody's going to ask you the difference between the inquiry, this and the one type of inquiry and so on. Not at this level. A question, let me give you an example. Discuss the views of two of the learning theories. David Ausubel, Jerome Bruner, Robert Gain, and John Piaget, highlighting the similarities and differences in their learning theories. That was one assignment. Part of one assignment. Describe the impact of these views on educational practice in science as they relate to the curriculum and the teaching methodologies used at the primary, secondary, and tertiary level. Word limit, 2,000 words. That is one assignment. So this was the assignment given, and I need to just fix this assignment for Friday to make it ready for you to do it for submission for the next week. So you're not going to take it and make the assignment into saying to you the difference between different types of discovery learning. Okay? Not that deep.
Yes.
Ava?
Yeah, sorry, but I'm thinking we had an assignment to do for Friday, the one that you had, unless I'm missing something. Because these days I'm in and out. You told me the learning style, the question. So that's due this Friday.
Yes, and that will be a 10% discussion type that you're going to do. We're going to discuss the what you think, and you're going to also write your response on the page for submission.
Oh, I thought it had. I'm happy to clarify because I thought we had to do it individually and send it to you.
You're going
That's
to
I was
write
thinking.
your response so that you can upload it on the Learning Exchange. You're going to write it. You're going to write your response, type your response so that I can find out from the lab technician that how you will upload your response, and then we're going to discuss it in class. And you will get the marks for the discussion. Okay? After we finish the discussion.
Okay,
and you will get another assignment. Right? The coursework values 60% for this course, and the exam, I think the core, what they said, we'll work out what it is. I think the exam values 60 and the coursework values 40, something like that. So I have to organize when you get another test and when you get another assignment. But you can't give people tests and assignments if you don't teach them anything, can you? You do that?
I just want to be clear. I just wanted to be clear that we do the assignment and submit it on Friday. I just wanted to be clear.
Yeah, the one that has you thinking about the critical, about those learning, those 3 scans, you can now do it for Friday.
Okay then.
Is that clear for everybody? Because we have gone through learning styles, and you have more work to do. You have more reading that you can do for those children.
Yes, we are just on Fridays. We normally get before the deadline is Friday afternoon. We just wait. Well, I just wait late because I'm saying if you're going to discuss it on Friday class, we probably have to give it to you before the class.
The assignment is due in class, please, people. I think that before students meet me, they have met some gores.
No, that's not what we are. Sorry. Just let me clarify. Sorry. Normally, we would have our assignment, we'll do it ourselves, and then we upload it. Let's say you said Friday, we'll work on it, and on Friday, maybe before Saturday reach, we'll upload it, or we email it to the lecturer. That's how it's normally done.
Are you trying to technically ask me for an extension on the assignment?
No, not at all. Not at all. I'm saying if you say we're going to discuss the assignment June class time, which is at 10 o'clock, we have to finish it before 10 so we can discuss it. I'm thinking, no? Or we discuss and then right after.
But can't you discuss, can't you, the assignment is in a discussion forum. Isn't there that where it is mounted on the OUVRL now?
Yes, we see it.
So you can put up your discussion points and somebody else can put up theirs and I can see it. And they can respond to it. And I'm saying that you are to write what you are thinking, your response, put your response in writing so that you can also email it. You can email an attachment. Huh? You can.
Yes, doctor. You can.
Huh? Can't you email an attachment in a message?
Yes, we can, doctor.
Huh? After the discussion in the class? Or before? Once I get it on Friday, isn't it Friday?
Yes, doctor.
Lee Platt.
Sorry.
I don't. It's 5 minutes to 2. Listen to me. You see, the longer you take to do an assignment, the more you overdo it. And when food is overcooked, it cannot be eaten. We have much more work to do than that one little simple thing. I don't want any long, drawn-out thing. I don't know what you expect to do with it. You're not psychologists. I don't expect you to do anything with it more than what you're asked there. And based on the knowledge that you have received, do the assignment. Stop procrastinating. You have enough knowledge to do the assignment. Come on. Samuel, what you learned, what you didn't like, and what you liked.
Yes,
we have
what
4
got
minutes.
into me? Yes, what got into me about the concrete and the abstracts, that in teaching we should be very careful as a teacher that even with the syllabus from C6 start with atoms and matter, we should always start it with a topic that's concrete. I think that I really got that clearly, because sometimes I want to stick to what the syllabus says we should start with. So it's very important that we should start with a topic that's concrete instead of abstract, like you said, like the atom. So that's what I got that clear. What I didn't like, it has a lot to do about me that I've not really been using event that describe, like the example you showed to us. I've not really been using that in class. So I think I don't like it about myself. And when we resume September, I have to get more events that I can show to them to introduce the topic. And what I like is about the difference between the pure and guided discovery, that will help me to see how I can incorporate that in my lesson come September.
Okay. All right. Thank you. Tracy?
I learned in the lesson that it's a good idea to do the marking during the lesson to point out how they're improving. And I liked learning about how to anchor the information that you're trying to teach to the students to information they previously had. I didn't like that there's too much time between breaks. I'm a person that I'm good for 1 hour, then I have to get up for like 5 minutes. So for me, I'd like more breaks. They don't have to be long, just enough to freshen my brain.
Okay. I need you to say that again. You prefer more breaks?
short breaks, but more of them. I just need to, like, after an hour, I start looking out the window, looking at the dog, and then I realize that I've missed like time. So just like 5 minutes every now and then.
All right. All right. Ashley. Hi, Ashley. Are you there? Our mic has been off. It seems as if Ashley is not here with us.
Hi, sorry, my Zoom just restarted for some reason. I don't know why.
Okay. Your Zoom was out.
Yeah, sorry about that.
Mm-hmm.
I guess I liked the clarification on what kind of learner I am most likely. I wish that there were more activities for us. Today's lecture, I don't know, it seemed like it was a little bit lengthy in your part of talking.
Mm-hmm.
Like said, it was a little bit difficult to focus today. I don't know if it's the weather here in Bermuda or it's what, but
it's me.
Other than that, oh no.
I felt a bit cranky. I was off put this morning. I started late, and that's what I didn't like. I started late, and I apologize for that. And so hopefully we get started early. I hope to get an activity in on Friday, and the internet connection was a bit unstable on this side, and I learned that I should prepare a backup for class just in case this internet thing doesn't work. I probably should try and email you guys the lecture because something might happen just before the lecture. Okay?
Thank you.
All right. Vanessa, my time is up. So I hope your throat gets better, and I'll see you guys on Friday. All right? Have a good afternoon.
Thank you.
All right.
Thank you.
All right. Bye-bye.
Thank you.
All right. Have a good day.